the convergence of digital and physical. It's physical infrastructure that also works better thanks to data and intelligence. The city of tomorrow is still going to be made of concrete and asphalt, but also of silicon and intelligence.
Hello, I'm Sue Nelson and welcome to the Create the Future podcast, brought to you by the Queen Elizabeth Prize for Engineering, celebrating engineering visionaries and inspiring creative minds. Today's guest is Carlo Ratti, who manages to straddle multiple jobs in a number of different countries. Apart from running several startup companies, he runs his own architectural practice in Italy and is also the director of MIT's Senseable City Laboratory in the United States, where he's a professor of urban technologies and planning. Carlo's background is in structural engineering, studying in Paris and Turin, and also architecture, with a PhD in architecture from Cambridge University in the UK. And while at MIT in the States during his postdoc, he became especially interested in computer science. Thank you for joining me, Carlo. We'll start with MIT and the Senseable City Lab. And I should add, by the way, for people listening, that sensible is not spelt with an I. It's sort of the word sense and then able. How would you describe the Senseable Lab?
Thank you, and great being with you, Sue, today. Well, yes, we call the lab sensible, like sense-able, with this double meaning of able to sense and sensible. And we like it instead of what people use many times is the word smart city. Now, I don't like it because it gives too much emphasis on the technological side of things. It's like, a computer for living in. And I like the idea of sensible, a city, again, that is using technologies, but puts people at the center.
Now, it combines design, engineering, science, computer science, urban imagination. What would you say is your aim then? If you don't like the word smart cities, what would you say is the aim of the sort of cities that you're interested in?
Well, first of all, I think, that there's a big battle going on in cities. Just four numbers about cities: 2, 55, 75, and 80. Cities are only 2% of the surface of the planet, but they're 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a little bit more sustainable, that can be a big deal globally. What can we do today? Today, there's a very interesting opportunity. And that is what is brought by the convergence of the digital and physical world. One way to say this is that the internet is becoming Internet of Things, is entering in the built environment, and is changing the way we can, for instance, describe cities using large amount of data. A lot of dimensions of cities that were not graspable just a few years ago can now be understood, again, through the lens of big data, analytics, and so on. And it's very, very important for, then starting to rethink how we can design and ultimately live in cities.
I would have thought that the problem is, though, that most cities are already in existence. So it's very rare that you'd be starting from scratch, which I suspect most people who are working on this would like. They'd like a clean piece of paper to start afresh. So is most of what you do having to adapt or upgrade existing technology and existing infrastructure?
Yes, actually, most of our work is about existing cities, existing infrastructure. The big challenge is really how can we make cities more sustainable, not really how to build new cities from scratch. And if you look at the 20th century, many times when people like Le Corbusier in Chandigarh in India or Niemeyer and Lucio Costa in Brazil, try to do a city from scratch, that resulted into kind of a disaster. And I think the important thing is really to recognize how cities grow organically, and today, how we can retrofit them to make them more sustainable.
So give me an example then of work that you've done or ideas that you have to retrofit an existing city to be more sustainable.
We could talk about many projects. Let me give you an example of a project which is based on data, a project we did at MIT a few years ago. And we started using data about mobility in the city of New York, about taxi mobility, other type of fleet mobility, the type of simple data that's collected by GPS and is shared with a central server. Incidentally, all of this data in New York was made accessible by Mike Bloomberg when he was mayor of New York. I remember Mike Bloomberg in his office had a sign that went, "In God we trust, everybody else bring data." And so he was so passionate about data that he opened up many data sets for researchers and for anybody to use. So we started looking at the data in the city of New York, and we started asking some questions. The first question I wanted to explore is something I think most of us have experienced. Imagine you're in New York, you're at a hotel, you're going to the airport, and next to you there's somebody else with a trolley, probably going to an airport, maybe exactly to the same airport where you're going. Well, you could have shared a taxi, you could have shared a ride, you simply didn't know it. So we decided we wanted to quantify the potential for sharing rides in New York. Imagine you want to take everybody to destination at a certain time, plus or minus a small delta, a small delay, 1, 2, or 3 minutes. Then how many trips could you combine? And we started looking at this a few years ago before Uber launched Uber Pool. We had a paper in the proceedings of the National Academy of Science. And that actually started a nice debate, a broader debate in New York, in different newspapers globally. And actually, then Uber reached out to us. So we started a collaboration, the first collaboration between MIT and Uber. And as you might know today, all over the world, Uber Pool allows exactly that, people to could go more or less in the same direction to share the ride. What we discovered in the paper is actually that we could cut fleets by 40% if people were ready to share a ride. So it's a very simple example of how data can help us understand better mobility, understand better the city, but also try to think about how we can redesign mobility systems.
So that's what you mean when I've read that you say that you deploy tools to learn about cities so that cities can learn about us. Is that sort of what you mean there, so that we get a better idea of how we're working sort of collectively, what we're doing, and then how we can improve that to save resources?
Yes, it's about the knowledge we gain from data. Sometimes it's data we collect in a so-called opportunistic way, from existing networks, as in this case with mobility and taxi data. Sometimes it's data we need to collect using sensors. We've been deploying a lot of sensors in Boston, in New York, in many other cities. But then, that gives us a better knowledge of the city, and that's the beginning then for action, for design, for transformation. And by the way, we should perhaps think about design. The definition of design, like most, is the definition that was given by Herbert Simon, great researcher, Nobel Prize winner from the past century. He said the natural sciences look at how the world is, but design looks at how the world ought to be or how it could be. So somehow for us, design is how we can use this knowledge in order to think about alternatives in the way a city works.
Now, when it comes to your architectural practice, then, how do you take existing cities and do the same and sort of make improvements?
So I'll give you, for instance, something we've been very passionate about over the past couple of years is a project in Helsinki, again, using both data and physical infrastructure to try to decarbonize the city. And the city of Helsinki a couple of years ago launched a moonshot challenge open to anybody, to teams from all over the world, in order to decarbonize the city, in particular to decarbonize the district heating system. Today, Helsinki is interesting because it has district heating, which is usually a good thing. You got a power plant, you have a byproduct, hot water, and you run the hot water through the district heating, again, heating the city. By the way, heating Helsinki clearly is a major source of energy consumption given the climate. It's a good system from an engineering point of view, but the problem is that the power plants are actually coal power plants. And the city has decided by the end of the decade to decommission them. And so the mayor was looking for innovative solutions to heat the city. And our solution is based on, call it thermal batteries, floating reservoirs, floating islands in the Bay of Helsinki. They're totally insulated, they contain hot water, and they become a way to use renewables when there's overproduction, turn it into into heat and then run into district heating. And again, we are working now to implement the first phase of the project, but it's just one example in which new infrastructure, in this case with a lot of artificial intelligence, with a lot of synchronization with the way the grid function, can help decarbonize a city.
I mean, I can see now why you describe yourselves as omni-disciplinary, because even just that one example that you've given me involves a huge array of expertise.
Yes, the Senseable City Lab, but also in our office, because the only way we can tackle today's big interdisciplinary challenges is if we come together from different disciplines. And I think architects, should forget about the old ideas, the 20th century idea of the Promethean architect. One person single-handedly making decisions for millions of people. I think we need to realize today is something much more choral. Is about being able to harmonize different voices.
When it comes to using lots of data, what are the sort of privacy issues there?
You're absolutely right. We always need to be very careful about privacy and about how we use data. I need to tell you, however, that today the issue is not really in the city, but the issue is much closer to us. It is really in our pockets. If you carry a smartphone today, your smartphone, by the end of today, will have collected thousands of data points about where you were, what you were doing, about the mode of transportation. The accelerometer can also help infer many other things about your activities that day. And the problem today is that all the data is collected. So there's companies that know a lot about us, but we know very little about them. And I really think we should have a broader conversation about data. We tried at MIT just before COVID. We had a number of conferences called Engaging Data, where we had people, privacy advocates, people from the tech companies, and academics debating this. So that's certainly a very important topic. But it's not necessarily an issue in the city, especially when you collect data that's already there, such as what we were saying before. But it is really an issue about what happens in our pockets and how we can be more transparent in this kind of, call it, data contract.
You had a project I saw on the Sensible MIT website called Stockholm 19. Perhaps you could explain for people what that involved.
Yeah, we've been doing a lot of work during COVID to see what, I refer to probably different projects we've been doing about what has been the impact of the past couple of years. And on the one side, we looked at cities and, for instance, how segregation has increased in cities because of different mobility patterns. Again, in cities is a beautiful, when cities emerged around 10,000 years ago, there is a beautiful way to bring us together so that together we can be more than each of us individually. And but cities also, if we don't plan them right, they can also segregate, create enclaves. And certainly COVID also pushed us in our on neighborhoods. We've been connecting less, and so we've been looking at segregation, how segregation has changed during COVID. In a similar way, we've been looking at the MIT campus, and we discovered something very interesting, that if we do not meet in physical space, then what happens is that our social networks suffer. We lose what sociologists call weak ties, which are very, very important for creativity and for reaching out to other communities. So again, what we've been doing is looking at data to better understand the impact of this kind of incredible change that happened globally about mobility, about connectivity, and how we could hopefully heal better now that things are opening up.
Some of your project ideas, they did make my eyebrows raise a bit because I wasn't sure whether it was science fiction or a stroke of genius. Your space bubbles to deflect solar radiation.
First of all, let me say this is a very interdisciplinary project. It's not only at the lab, but it's a project that was inspired by a very interesting idea proposed now over a decade ago by Roger Angel. And Roger Angel is an astrophysicist. Started thinking about how we can contrast climate change And clearly, if we reduce a little bit of the energy coming to the Earth, we can reflect it or deflect it. Then just 2% of the incoming energy, if we're able to reflect it or deflect it, would allow us to again to contrast climate change. Now, let's be totally clear. This is part of those umbrella of projects called geoengineering. I think we should first try to see if we can address things in just by climate mitigation and adaptation. But if things were to get out of control, it might be good to have a solution based on geoengineering. You don't want to do geoengineering on the surface of the planet; that's too risky. And so, what Roger Angel proposed at the time was, what about putting outside of the planet something like a thin film mirror, able to again make sure that 2% of the incoming energy from the sun doesn't reach the planet, and hence combating climate change. Now, there was a theoretical paper published also in PNAS, the Proceeding National Academy of Science, and they started a very interesting debate. Several people think that this is probably the only option one should consider in terms of geoengineering, but there's still many technical issues that are open. How can you do that? How can you put a surface, a reflective surface the size of Brazil in space in between the Earth and the sun? And so in this project, what we started thinking is how we can really engineer this. And some of the most effective thin films are actually use the Marangoni effect, are based on thin film bubbles. And so the idea is to fabricate them in space, and so that you minimize the amount of matter, and also you can make them reversible, so you can easily control. If anything is going to get out of control, you can easily destroy them. That's what we're looking at together with many colleagues from material science, from civil engineering, from astrophysics at MIT. So it's really, really interdisciplinary and collaborative project.
So how does engineering inform some of your design solutions that you come up with at the lab?
The way I see engineering, as we were saying before, is engineering design. So the same definition by Herbert Simon, looking not at how things are, but how things ought to be or they could be. And from this point of view, we see that it's very important we bring different disciplines together. Again, at the lab, we got people from traditional engineering, from architecture, from planning, but also from complex science, from mathematics, physics, economics, you name it, coming together in order, again, to look at how cities could be transformed. But let me add something very, very important. I think we don't believe that what we develop are the solutions. We think that we should develop possible ideas and then start a conversation. Ultimately, citizens should be the one to decide what type of city they want. So the important thing is that there's a feedback loop between ideas generated and the response by society.
I'm glad you said that, actually, because it is like you say, it is important that you get this cross-discipline approach at a sort of effectively an academic level, but also it's usually people who live in cities who can tell you, I don't want to walk down that area because it's too dark, or I don't feel comfortable. If you're a woman, for instance, who will have a very different approach to how a city is constructed to a man, and it's only when you live there that you see what works and what doesn't.
Absolutely, and it should be citizens to decide if they want to have a city tomorrow that's more, where mobility is car-based, or with more bikes, or a more pedestrian-friendly city. So somehow, I think that what we should do, I like to think about designers, and by this I mean also engineers as part of the bigger family of designers, as mutagens. And so what we need to do is actually try to propose ideas how things could change, but then ultimately that should just be the beginning of a feedback loop, and citizens should be the one to make the final call.
What would you say are like a sort of future city to not necessarily look like, but work? How ideally would all that data work together in your eyes?
Yeah. Well, the data we collect really allows us to understand dimensions of a city that we couldn't understand just 10 or 20 years ago. And that was an old dream of architecture, planning, engineering. Think about Ildefonso Cerdà. Ildefonso Cerdà, the father of modern Barcelona, the person who in the second half of the 19th century designed the major extension of Barcelona, so-called Eixample. In his book on the general theory of urbanization, he says he dreams about the day when, transforming a city would become like a science, really through the availability of data. Well, it took over 100 years, but now the data is available. And so the data is the beginning of how we can better understand different dimensions that were much more difficult to measure or impossible to measure before, about human interactions, about people, about moving, about activities. We could measure the city, the physical city, but not the life inside the city. And then that is the beginning of trying to imagine different type of future cities, and through the feedback of citizens decide where to go. Let me add by saying something else. Another way to answer your question is, I don't think there is an ideal city as people thought in during the Renaissance. I think the nice thing today is that you got people across the planet in different cities looking at data in different ways. And so maybe the ideal city is a mosaic of all the experiments happening in different countries. Those in Singapore about the future of mobility, in Copenhagen about sustainability, in Milan focusing a lot on bringing nature to the inner center of cities, in Boston trying to increase citizen participation. Probably the ideal city of today is not like the ideal city of the Renaissance. It's like a collection of a mosaic of all these different experiments happening globally.
Do you think then for future cities, the balance will shift from engineering and architecture towards data, or do you think it's going to be a sort of balance between all of those?
I would say that data is becoming more and more important, but you know what? Our students at MIT graduating in architecture today, they're very conversant with data. They're also programmers, and the same applies and even more so to engineering students. So I think that is going to be very, very important, but it's going to be part of what we said at the beginning, the convergence of digital and physical. It's physical infrastructure that also works better thanks to data and intelligence. Somehow I would say that the city of tomorrow is still going to be made of concrete and asphalt, but also of silicon, intelligence.
Oh, that's good. Now, you're a member of the World Economic Forum Global Future Council on cities. What does that involve?
I've been serving on the Global Future Council on Cities at the World Economic Forum now for a few years. And what I think is very interesting is that the forum is a very good platform for bringing together different parts of society. And so on the council, there's certainly people from academia, there's researchers, but you also have governments, city governments, mayors, public administrations, and you also have industry. And again, it's part of what we were saying before. The city is really collaborative in nature, and the only way to tackle its complexity is to bring together all the different stakeholders.
Now, you've said before that the role of the laboratory ends with the urban demo. Why don't you push ideas into commercialization?
That's precisely why over the past few years we have a number of spin-offs, both from the lab, from our research lab at MIT, and from our design office, in order really to turn some of those ideas into real things. The mechanism is quite well known. A lot of colleagues at MIT do the same. It's about you do a startup, you get some funding, you take an idea from the lab, and that is the one that's then replicated at scale. So somehow you cannot do scale up from a university setting, but you can do it if you create a spin-off or a startup.
Is that what attracted you then to being involved with a number of startup companies?
Yes, it is actually the first one that's run by Asaf Biderman. Asaf has been started the lab with me. He's associate director of the lab, and he's the CEO of the company. Is now one of the top 5 players globally in micromobility. Again, micromobility is the idea that when you do the last mile in cities, in most cities actually, the majority of trips is under 2 miles. And well, it doesn't make sense to move 1 or 2 tons of steel for 1 or 2 miles. You can have smaller vehicles, from scooters to proper cars, but smaller vehicles and fleets that you can get on demand to do this kind of shorter displacements in city. And Super Pedestrian, the first company we started, is now one of the top 5 players globally in this space. But we started some other companies dealing with other than urban dimensions. And again, that is very important to us, really precisely for what you said before, how to take an idea from the lab and turn it into the city.
And your design firm has featured 3 times now in Time magazine with best inventions of the year. What for you is the invention that you've done that sort of perhaps is your personal favourite?
I would say if I had to mention more, what I would say the invention that I would favor is really about how we can work in a different way in a collaborative sense. How we can go beyond the approach of architecture and engineering in the 20th century and really think about much more interdisciplinary groups. And again, it's I think we're one of the few places at MIT, for instance, where you have computer scientists, physicists, mathematicians working together with designers. They will learn from each other. Some of them at the beginning they arrive, the first one want to publish in Nature, the other ones want to exhibit at MoMA, and after they've been working together for 6 months or 12 months, they realize that really it is a unified field. It is about having impact, especially in the built environment.
And that impact, you mentioned MoMA there, which is the Museum of Modern Art in New York, and you've had your work exhibited at quite a range of different venues like London Science Museum, design museums in Barcelona, and also like the Guggenheim at New York as well. Does that really help you sort of get this cross-discipline approach to different audiences?
Well, the reason we think that is important, and it's also the reason why we do a lot of visualizations for our projects, is that we were saying before the important thing is to get feedback. So to try something, to propose, again, a mutation in the built environment. And then you get feedback from people and understand the good and the bad. Sometimes you even want to propose something where you're not completely sure it's the right direction. But again, it's always good to start a debate about it. Sometimes you can build antibodies for something that you don't want to, for a direction you don't want to necessarily explore. And for that, there's many channels. So the channel of museums is one, the channels of visualizations that go online, the channels of media. So that's why I was so excited also to talk to you, because really the only way we can do better cities is if we propose ideas, but especially get feedback back from citizens.
And those ideas, as we've already discussed so far, really do range from floating batteries in Helsinki to the massive space bubble. You've also been involved with trying to do something called a Copenhagen wheel, which converts an ordinary bicycle to a sort of hybrid. The world's first robotic bar system. I mean, there seems to be just ideas coming left, right, and centre here. Are there any that you've learnt from more than others? Because engineers, in particular, always say that you learn from your failures as well as your successes. Is there something where you think, well, that didn't quite work out, but do you know what? We learnt a huge amount from it.
Yeah, well, one of the things we learned over the years is also that sometimes you fall in love with an idea. But if you fall in love with your idea, and for instance, you forget about the economic side, or you forget about politics, then it's not going to be realized. And it happened to us many times. We had a beautiful project I loved for the London Olympics. We developed it for the then Mayor Boris Johnson before 2012, and that project in the end wasn't built. But it was probably a mix of not looking too much in detail at politics, economics, and so on. So I think, as engineers, as architects, sometimes we fall in love with an idea. And I think, but the important thing, we should fall in love with impact. And impact means you might need to revise your idea in order to make it a reality. That's, I think, the important thing, especially in that feedback loop we were discussing before.
And have you ever used permanent magnets in any of your ideas?
We did actually, for instance, in the Copenhagen wheel that you mentioned before, this kind of small KERS system. KERS is like a kinetic system that's used in Formula One. We did a very small one to apply to your bike, and that was actually the beginning of Super Pedestrian, the company we mentioned before. So yes, there were permanent magnets.
That's good. The only reason I ask is because that was the winning invention of this year's Queen Elizabeth Prize for engineering. Is there a particular engineering innovation you think is perhaps hasn't had the spotlight on it as it should, or you'd like to see win the prize one day?
I think there is an old dream in engineering, and that's about having a material that will allow us to have space elevator. That's really going to change things. By the way, that was a dream of a science fiction writer, Arthur
Arthur C.
Clarke.
Clarke, yes.
Exactly, it was a dream, but actually in Fountains of Paradise, if I'm not wrong. But that is also something that was discussed. It was a nice exhibition, the Science Museum in London with Norman Foster. That was probably 20 years ago. Where actually new materials based on nanotubes, carbon nanotubes, were studied and explored because those could allow us. We're still able to make very short nanotubes. So if you're able to scale up, well, those could allow us to get to that level, to have a rope that doesn't break under its own weight, but can allow us to do something like a space elevator, and that would totally change the way we inhabit the Earth and the atmosphere.
I love it. Love that idea. Carlo Ratti, thank you very much for joining me on the Create the Future podcast.
Thank you very much for having me.
Find out more about the Queen Elizabeth Prize for Engineering by following QE Prize on Twitter and Instagram, or visit qeprize.org. Thanks for listening, and join me again next time.